Let's start. My name is Mikhail. I'm here to speak about F# today. Thanks for coming this morning. So last year was my first Tech Days when I just attended it as a visitor, and I came there. I was pretty interested in F# for a couple of years, so I was expecting to get some F# sessions there. But when I came there, it looks a bit like that. There was literally 0 F# sessions last year, so I decided to fix it this year, and that's why I'm here. Actually, it's even better than that, because this year we have 2 sessions. Rolf will have a session this afternoon, so please join that one as well. It's probably very interesting and so on, but I have one problem with the title of his session, and that's quantum computers and stuff. Quite often F# is perceived as a very niche language, like it's only for mathematics, or it's only for science, or finance is very popular. But my point to make today is that it's a general purpose programming language. It has some vocabulary which is different from traditional object-oriented languages, which you need to learn. You also need to unlearn some other stuff which you learned before. But once you are there, you can use it for pretty much anything, at least for any modern application. You probably will not be able to do Silverlight with it. So the plan for my session is the following. I want to take a boring business domain, implement a sample application, very simple one because I only have 40 minutes, backend application, and I'll use the familiar approach, like other words that you might see or hear on other sessions, like domain-driven design, event sourcing, CQRS and stuff. But I'll use F# for this, and I'll show how you can look at those concepts a little bit differently. So I'll build a bridge from what you already know to maybe what you don't know yet. By the way, raise your hand if you know some F#. Okay, that's more or less what I expected. That's perfect. And I also deploy it to Azure, so it's just to show that it's modern and suitable for us. So let's start. My business domain is issue tracker, so we'll do something like a Jira backend, or rather simple to-do app. Yeah, I told you it's going to be boring. But I picked this domain just because everyone in this room is probably familiar with it, and I don't have to explain any concept or stuff, spend time on that. I'll just do F#, goodness. So let's start. I want to start from really basics. So from the first inception phase of the project, which I'll call Brainstorming. That's a term for that. So what it looks like, you get all the domain experts in one room, and they start to brainstorm what kind of events they will have in their business process or in the future application. And you try to get diverse people in the room and also technical people, so the technical people can learn, get the language at first, learn how to speak the same language as domain experts, pick up some concepts, and then go back to their office and start programming. So how it looks like, basically there is a bunch of sticker nodes. Every domain expert can write an event on the sticker node and put it on the big wall. Everybody does that, and then they discuss. They ask questions. I don't know what that means, how that works, and so on. They collaborate on that. Then maybe because people come from different backgrounds, they will also come up with slightly different events, and maybe you will be able to identify some grouping of those events. Like in our example, it could be that some events are related to issue lifecycle management, and others are like more about release management. So those groups will be good candidates for future bounded context in your application, if you know what I mean. So the vertical slices, which you'll be able to build around those concepts. So that's important. And the last step that I want to mention, that you can come up with triggers or actions, like what leads to this event happening, and then put a blue sticky note next to a yellow one, and then try to start thinking about workflows. So what goes afterward. So that's it for brainstorming for now. Then the technical people go back to their dungeons, and they start writing code. And they of course start with domain. That's how they should do. They model the domain, the concepts that they learned. They transfer the worlds into the code. So I'm not going to model with anything like UML or database schemas. I just do the functional modeling. And for that, I need three elements: types, functions, and pipelines. So a type is a shape of data. It's nothing more than that. So you define a type as like which properties it might have, what's in there. It doesn't have any inherited operation in it. So it's like a data container, but it's exact shape of the data container. It defines a set of possible values for that type, like an integer or event is a type. Then we define functions, which are mappings from one type to the other. You get one type as input, return another type as output. They don't do any nasty things like calling database. It's just a function. So for each value in type A, they know which value from type B should be returned. That's it. And when you have a lot of those things, you can combine them on matching types, and then you produce pipelines. So when you have lots of small, simple functions, you combine them to produce something more sophisticated. That's the whole story. So I'll have two scenarios for today. The first one is create an issue. It's going to be super simple. We'll just go through all the steps, and then the second scenario will be slightly more advanced. So create an issue. Let's start writing code. We define our first type in F#. This is called a record. It has three properties, all strings for now. And yeah, you can think of this like a C#. In C#, it's a class with three read-only fields. Read-only because this is immutable. All the types in F# by default are immutable. So once you create the value of that one, you cannot change it anymore. And that actually maps very good to the domain concept of event. Event is something from the past. So you created it, and it doesn't really make sense to change it because it already happened. So I have one problem with this type is title and description are probably strings, but ID, if you ask the main expert, it's probably not a string. They don't talk about it like that. They have a concept for issue ID, like in Jira you have project number with something. So the way you solve it, you define a type for issue ID. In this case, you just say that you tag it with something called ID. It's still a string inside, but it's not anymore compatible to strings. It's a separate type. It's a separate concept that you can reuse. And if you try to assign ID to title to something stupid like that, it will not compile. In the future, you can refactor it to something more sophisticated, like project code and a number or GUID or whatever. But at least for now, we'll have a concept for issue ID in our domain, and we can reason about that and reuse it in other parts. So we have our event. Let's make one step further and create a command. So our blue sticky notes. Command is an intention, like to do something for me. And then the way we link it to event, we create a function which maps command to event. Simple. And we'll use this concept throughout the talk, so be familiar with it. The type for command, very simple, it just has title and description because ID will be created by our system. That's how we decided. And that's our first function for today. You define a function with let keyword, then goes the name, then argument, command in this case, and the function body goes after equals, and body is always an expression, so it's not like do something, it returns something. In this case, it returns an event. Notice that I did not use explicitly the name of the event in the code. F# compiler can infer this type based on the previous code that I defined above. So I defined the event, then I define a function, and based on the property names that I used in the body, it just understands, oh, that's your event. And function is actually also has a type. The type is shown on the bottom. Each function has a type. When you see error in the type, that means that's a function, and it maps command to event. So that's easy. In your mind, it's easy to map it to the previous picture that I have before, just by looking at the type of function. So just to recap all the code that we did so far, I put it into a module, so like a container, more or less like a static class or something. And yeah, nothing new here. So next step would be to define an API. We defined our domain, that's our code, that's internal for us. That's how we model the domain, but we don't want to expose this directly to outside world because it's nasty and it speaks JSON and database and stuff. And we want to keep our domain clean. So the plan for the whole application is that we'll have a HTTP request coming into our REST API. They will send JSON bodies. Then framework or something will convert it to a DTO, like it always happens in .NET. And then we want to pass this to our function, which we are about to create soon. And the function should produce event log. That's because I want to use event sourcing for my storage. Event sourcing, if you're not familiar, means that we store all the history of everything as collection of events. And when something happens, we append the new event to the end. And we store that as a source of truth. So every time we need to do something, we load that history of event, we kind of replay it to understand what's our current status, and then we make a decision based on that. So the benefit is that you always you never lose information, you only append stuff to the end. And also it maps very nice to functional concepts, so I want to illustrate this. So in our case of creation, the event log will have just one event, obviously, create event, but later on we'll add more. And this function should produce this event log with one event, and then I want to store it to database, to document database in this case. So that's the plan. A bit driven inside, these are the types and functions that I want to create. So the browser sends DTO, then we parse it into command. We pass it to our nice and clean domain. Domain produces event. Then we call a function to initialize history with just one event. We get DTO from that function, and we put it into database. Simple. So it's very linear pipeline, and our domains sits inside this pipeline. So let's quickly implement that. These are our DTOs. I chose to put attributes on them. You can do serialization other ways, but I just wanted to make sure that you see that this is something ugly from the outside world. So properties are lowercase, so that because they come in JSON, again, you can solve it other ways. But these are DTOs. These are not your domain things. And then I define a module, serialization, deserialization, with functions which are quite straightforward. We have two functions here. One is parsing DTO and producing command. It's just copying properties for now. And then initialize history goes the other direction. It gets the main event and it produces DTO to be stored in the database. Probably the only interesting line here is this let ID stream. That's because we have our issue ID type. So we cannot just assign that thing to string because we wrapped it into ID. So we need this is a simple form of pattern matching. So we say that I know that event ID is not a string, it's something with tag ID and string. In this way I can extract it from that type. If I would just try to assign ID to ID, that will fail, compile, error. So given that, we can finally produce our API. I call it create function. It gets a DTO. The last line is it returns event log. Again, we don't write to database anything yet. We just return. And the rest is like get the data, call a function, get the result, put it in the next function, get the result, put the next function, get the result. So it's very linear. And that's actually a good property of this code because it's like a composition code. It shouldn't contain logic. Actually, because this kind of code is very typical in F#, there is a language feature to make this code much smaller. So this is the same code. It has operator, greater. It's function composition. So it does exactly what we did before. It takes the result from the previous function and pipes it into this next function. that illustrates my concept that you need to know some approaches which are different from what you are used to, but once you learn this, it becomes really easy to read the functions like that. It's not like even code, it's configuration maybe. And of course this is type safe, so if you are trying to do some weird stuff and combine them in the wrong order, this will not compile. So let's put our awesome API into Azure now. My plan is to use Azure Functions for that. They have first-class support for F#, so you can do it in Portal, you can do it in Visual Studio. Create Azure Function. If you don't know what Azure Function is, that's a serverless service from Azure. So you just define events, and then you define a code which should be run when this event happens. And then it will run. There is no like server. And then I want to put the result of my function, so the event log, into Cosmos DB, which is the new name of document DB if you don't know. That's the plan. And that's the code, all the code that I need. If you are not familiar with Azure Functions, maybe that looks a bit bogus, but it's again more of configuration than coding. You define HTTP trigger. You say that I want for the post for this URL for function, I want to get DTO. And then I have output of my function, denoted by collector type, which is called documents, and it's bound to issues database in document DB and issues collection. And then the last 3 lines is actually the body of this Azure function. It calls API, gets the event log, adds it to the documents, and return ID to the caller, so they know which issue ID they are working with. Is that more or less clear? Okay. So what we've seen so far, we created 5 types. It was very easy, just several lines of code. 3 functions, we composed them into pipeline. And what's important, we didn't do any non-deterministic operations. We didn't call any database. We didn't write anything to the file or whatever like that. So that's the general strategy for functional architecture. We put pure, nice functions as our core in domain. And then we push all the nastiness of the world to the outside boundaries. So we do it in the most stupid or straightforward functions that we can find, and that we make sure that nothing else depends on them as far as possible. So that was the first scenario. It was super trivial, like no logic anywhere. So let's make it a little bit more complicated. Let's change this issue now. We go through all the steps. We start with the main modeling. Let's say we decided to pick 4 events from our experts. Assign an issue to a user, adding comment to the issue, close an issue as done, and then reopen an issue. And we follow the same path. We define the type for user, just a container of string again with different tag. And then we say that the signed event is just the user. We don't need to put ID or anything else because we will use those events in context of already existing issue. I'll show you later. Then comment event is just the user plus his comment, simple. And let's say for now I didn't have any properties to put to closed and reopened event. I could probably define them as empty, but that's actually not a valid F# code. So I'll show you a better way in a minute. Let's keep it commented out for now. Then we might start the same way we did last time and do a simple function which just copies a property from command to event. But then actually the main expert comes in and says, that's not how it works, because if issue is already closed, it's done, then I don't want to assign it to anyone. So somebody can probably send a command to our API, but it might fail. It's not a valid transition. When issue is done, we should not be able to assign it. Okay, we got this knowledge from the main expert, so we want to modify our code. And the first notion that we got from him is that we have a new type, as always in F#. And this is new kind of type. It's in F# it's called discriminated union. I'll call it choice type for simplicity. So that basically means that it has one of the two values. It's either new or done. This one looks like C# enumeration, but it's actually much more powerful. You'll see it again in a minute. But important thing is it either or. So it cannot be both at the same time. It also cannot be none of them. So it's always one of the two. And then what's the plan for my assign issue function? Well, it now it now needs two arguments instead of one, the command and the previous status of the issue, whether it's new or done. And then on the right side, I want to return either event if operation succeeded or an error if it failed. And notice that I don't want to use exceptions and stuff like that. I want to model this in my type system. So this fancy arrow on the right, it means that either or. I want to return one of the two things, but not at the same time. And also not none of them. So how do I model this right side of the picture? Of course with a type like this. It's again a choice type. It has two choice options, OK or error. But it's more advanced in two ways. First, it's generic, so it has two generic arguments like C# class would, T success and T error. And then for each case, we define that if we have a value of this option, OK, then we want a piece of data of type T success with it. If it's error, then we want to have another piece of type error. So that gets quite powerful, and that's actually a built-in F# type, so you shouldn't define your own. You can, but you shouldn't. And it's used pretty much everywhere. And then we want to use it for our function. That's a second iteration of my assign issue function. It accepts two arguments, as you see now, status and command. And then it uses match statement or expression to like ask if status is new, okay, do something. If it's done, do something else. It's more or less like switch in C#, but again much more powerful. And if it's new, we return OK. So the case here is OK. So we return OK, and then we return a value of event. If it's error, then we would just return a string with a message for the user. We could return another type, but string is simple. So on the top, you can see the type of this function. It's with two arrows, it denotes that it has two parameters, and the result is result of event and string. So just by reading the type somewhere, you can already imagine what this function does. You can say, okay, it accepts two arguments, and it doesn't always return event. It might fail. I need to do something with the result. If you try to make a pipeline somewhere where the other functions don't expect the result, it will not compile. It will say, you need to handle result somehow. So that's supposed into exception when you just can ignore it and compose your code without handling exception properly. So we can go on and apply the same pattern for other functions to create events in our system, close and reopen. Same exact thing. We are matching with status, and let's say if the issue is already closed, we don't want to close it again. We don't want to produce a new event. We just throw an error. We could just ignore it, but I want to be explicit and throw an error. Not throw, return an error. So how do we expose this to our API now? We have like 4 functions, 8 types. It's a bit messy. So I wanted to create to keep it as clear as we had for create function, create scenario. So I define a higher level types. I have just one change issue command and one event changed command. Oh, event change event. In C# maybe you could simulate this with base class and then derived classes. This is actually much more clear in F# because this is a closed choice type. You cannot, like in your other project, add the 5th option to this type. and then everything breaks. So it's a closed definition and very easy to read. You say that if my command can be assigned, and then it has this proper data type associated with it. If it's add comment, it will have add comment properties. And here we solved the close and reopen command issue that we didn't have any data associated with it. So we don't have to define a special type for it. We just say R. It's a case in change issue command. Now we can define our domain function, the first iteration. It gets command status, and then again it uses match expression to understand which exactly command it is, and then return a proper function. Note that match expression is now more powerful. It's not just a case, it's also defines the local value A or C in this case. And these are strongly typed, so A has type of assign issue command, C has type of issue count event command. And that's why this compiles, because you can pass it to the functions which accept those types. It's all safe from compilation point of view. And also, if you're like tomorrow add the fifth type for a command and then you forget to update this one, the compiler will tell you, actually in this match statement you are not handling all the possible values of the type, so please do. So once you add a new command, it's very easy to find all the places where it's being used just by compiling and fill in extra cases. But we still have one problem here, because we accept status and we still don't know where do we get it from. I said that we are using event sourcing, so we need a type for this in our domain. And again, I want to model it precisely, so I say that issue events is exactly one created event, always. You cannot have issue history without events. This is non-nullable. All the types in F# by default are non-nullable. You cannot assign null to it. So the code will not compile unless you provide an instance of event for this history. Again, it's guarding us from making stupid mistakes. And then the changes, can have 0, I can have 1000, doesn't matter. I model it with the list of events, of change events. So this history will always be valid, at least it will on a high level. And then, of course, I define a function, replay, which gets event log and produces status. This is probably the most functional, geeky statement in the whole presentation. If you ever did aggregate statement in LinkQ, that's the same thing. List false, so it goes through all the events in collection. It starts with a new status, and for each event in the collection, it calls apply function, which will return the status after applying this event. So you take the event first, you say, is it closed? No. Is it closed? No. So it's still new. Then you find closed, for example, then your issue status becomes done. You pass it to the next event, so on, so on. In the end, you get the end result for the current history. So given that, we have everything to define our domain. That's a picture. It's on the boundaries of domain, so public contract that we expose to service. We have command and event log, and it returns either event or error, as we remember. Implementation is pretty straightforward compared to the previous one. I substitute status with events, and then call replay function to get the status, and then the rest is the same, what we already saw. So that's our domain public contract next to create issue function, which I defined earlier. Okay, let's go to API and hosting. Same story. The big picture looks complicated, but our domain sits in the middle of it again. These contracts that I defined earlier, you can see there. Then browser sends a request on the left side. We get a command DTO. We parse it with a function deserialization. We get a command at the same time from the document DB or Cosmos DB. we load event log DTR. Again, we parse it into our nice domain concept. Then we pass both to domain. We get either event or error. In both cases, we need to return something to the caller, so we produce HTTP response, either 200 if it's okay, or 400 if it's bad request or something like that. And only in case of successful event creation, we append this event to the log, and then we store it back to Cosmos DB. So that's implementation. You see that I'm working in module API. It has change function. It accepts 2 arguments, issue command DTO and event log DTO. Then it calls our serialization code to get our nice clean domain concepts. We call domain, we get the result. You remember result is either event or string error. And then we call 2 additional functions. One is to append result to the log. Only if the result is successful, that function will take care of that. And the last statement is always return statement in F#. There is no return word because it's always true. It returns HTTP response to the client based on the result of our calculation. So I think serialization, deserialization is too boring to show. So I only want to show you this as example of handling result. Several interesting notes about this function. First, I did not annotate any type for result argument. Again, compiler infers the type, in this case based on the body of the function. So because I use result to match it to OK or error, compiler knows, that's a result type, because it has those cases OK and error. And it automatically infers the type for my function. Also notice one important thing, the inferred type, which is shown on the bottom, it's actually generic, even though we pass our very concrete type with event to this function. Compiler then looks at the body, and then it understands that we actually didn't use the event anywhere in the body. This is the underscore after OK, says we don't care what's there, we just return HTTP OK. So this function is made automatically generic. We can put to utils or somewhere. And this probably wouldn't happen if you would have to define types yourself. You would not think of like, that's a generic thing, or at least not immediately. But compiler often does it for you, which is nice. And again, that's an example of matching. It has 2 cases, OK, error. In each case, it returns its own value, which has to be of the same type. Otherwise, it will not compile. And in this case, it's HTTP response message. So the last step for us is to implement Azure function again. The body of this function is super trivial. It's just one line, the last line. We call API, nothing more. And all the rest is just the configuration of Azure function. We say that it's a HTTP trigger still. It's a put instead of post. And we expect different DTO, which contains ID property. And then we say that we bind that ID property to the next argument with this expression next to ID. And how that works, the function app is smart enough to understand that this ID is taken from request. It takes this ID, it finds a document with this ID in Cosmos DB. It loads the document, it provides you with a state value. This one is mutable because I have to append event. I had to explicitly annotate this type as mutable. I didn't show it, but I have to say I'm allowed to change it. And then I pass it to API change function, which will change state potentially if everything was okay. And then function app will store it back to Cosmos DB for us. We don't have to do anything. If we change it, it will just put it instead of the previous document. It will take care of like all the API calls and potentially some retries errors. So that's very nice. Again, the concept of pulling all the nasty operations of broken outside world to the outer boundaries, in this case, to really outer layer of our application being Azure Functions. That's why they match so well. Okay. So that was all the code. What I still want to discuss briefly is my message that F# is a suitable language for general purpose modern applications. So what kind of concepts can you use it for? So let's say you start a new application and you want to use domain-driven design. That's a good thing. F# can help you because of its sophisticated and very nice type system, for example, choice types. So you can model your concept in domain more explicitly. You can say exactly which shape of the data you want and which state is legal and which state is not legal. At least you can go further than in languages like C#. Also because of same defaults in the language, like immutability by default, no nulls by default, no exceptions by default, you kind of get in more safe world. It's much more difficult to do errors like null reference exception or not handling exception properly. And as a result, you are striving to property of your code when illegal states are not representable in your code. So you cannot compile the code which doesn't meet the requirement of your domain. You cannot do it 100%, of course. There are rules which you cannot model with such type system. But at least you can go half of that way. And the side effect of this is that you get types as your documentation just by looking at the type of a function or just the type itself. You can already maybe reason about what's going on there and discuss it to semi-technical people. And types are guarded. Quite often your code will not compile, and when it compiles it works. So maybe you want to use event sourcing and CQRS and stuff. Traditional books and approaches show you the way to do it with aggregates, which have some mutable state inside. Then they have methods which accepts command. Then they publish events into bus somewhere. So what I don't like about that is that it's all non-deterministic and with side effects. So if you call the same method twice, you might get different results. And it's also not very straightforward, like test those things and subscribe to those event publishers and so on. So an alternative can be just modeling all those concepts with pure functions. You have your input, you return your output, done. Those functions are deterministic, so we can call them 1000 type. You get times with same arguments, you get the same result. And also the important property is totality. That means that for every input event, you have something to return. You don't blow up if you get -1 or something. You always model for each input event. I have to return something, and I have to model it in my type system. And given that, it's really easy to test those kind of things because pure functions are probably the most easiest, the most easiest thing in the world to test. You just create arguments, call it, and then you validate that you got the result properly. There are frameworks like fscheck, which goes one step forward, and instead of you having to define the input, you can just define a property of your function. Like if you are testing summation, a stupid thing to do, but still, you can say that adding any number to 0 results in the same number. And then this framework will go through all the possible numbers, will try to break your function in a way to break this property. Or like if you add a number and then subtract this number, you get the same result. And then if framework finds the way to break it, it will show you the exact case where it failed. For these trivial examples, of course, it will not fail, but quite often it will come up with like a list of 6 values which lead to something which you didn't expect. So that's nice. And the extra property is composability. So functions are super easy to compose if they match on types. If they don't match on types, then you have a different problem because you need to model something differently. But out of pure functions, you build higher order pure functions and you go turtles all the way. So are you familiar with things like onion architecture, portion adapters, and cleaner architecture, which is more or less the same thing? It says that you have to put, or you should put your domain in the center, and then all the dependencies should go to domain, but not from the domain to like database calls. So you invert the traditional layers and you put domain inside in the core, and that's your asset. That's what you care about. So everything else should reference it instead. Well, that's how you normally end up with when you do functional applications. What we did. This picture looks like ports and adapters in some way. We have a domain, and then servers uses it, but you cannot reference servers from a domain or use DTO somewhere. That's also true because F# as a compiler doesn't allow circular references or dependencies. So you cannot, at least in different modules, you cannot define types which reference each other. Like, that's not possible. At first it might look like limiting, but that's actually a great feature because if you define your domain first and then you define all the rest, then none of your junior developers can go to domain and start typing service method calls. That just doesn't compile. Finally, open source. Microsoft is all open source these days, but actually F# was the pioneer of open source in Microsoft. It was open source from day one, I think. And the community is really, really active. They are contributing to compiler, tooling, Visual Studio Code, everything. Creating libraries, documentation, their own. I think in Microsoft there are just a handful of people working on F#, and all the rest is done by the community. So if you are interested, go to fsharp.org. That's the website of F# Software Foundation, a non-profit which tries to popularize F#. They have nice Slack channels with help people. They have mentorship program where you can subscribe, and then if you are lucky, you'll get a mentor which will help you progress. They have lots of documentation, nice books, and so on. Everything is free. So just go there. And with that, thank you. If you have any questions, feel free to come by or ask from your place. And I have some F# stickers if you want. So go grab them. Thank you.